Hello everyone. In this lesson, you will learn which SDK functions enable the saving and loading of player data on the Yandex server. We'll also implement saving in our game. It's hard to imagine a game that doesn't have the save feature. When exiting the game, players expect to be able to continue from the same level, with all their coins and progress preserved. If you've worked in Unity before, you know that the save functionality can be implemented through player prefs, or by writing to a file on the user's device. This works in the browser, but won't transfer saved data if the user plays the game on a different device. Implementing saves using the SDK enables users to play across different devices. They can start on the computer, continue on their phone, and the progress won't be lost. Let's begin by creating a starting screen. So far, we've been creating levels, right? Here are a few levels. Now, we'll make a starting scene that opens upon game launch. It'll be a menu where the user can change some settings. There's also going to be a Go button, which will take them into the game and resume it at their last save point. Another reason we want this starting screen is to load all the data for the game. This data will then be used by these objects. This way, it'll be preloaded before the user actually starts playing. Create a new scene. I'll call it Start Menu. Now we'll put into it this progress object. Here's what the progress script looks like. There are fields here for the number of coins, width, and height. This code is a singleton class, meaning there's only one instance of it in the scene. It can be easily accessed by other scripts. We've also added Don't Destroy on Load, which will make it persist across all scenes. It's generated once on startup and exists throughout the rest of the scenes. Same with these fields, they're initialized once, and then remain in all the scenes. Let's drag the progress object to our starting scene. Unity is good when it comes to scene management. It lets you add several scenes to one project. This is our start menu, an empty scene. Let's delete directional light, we don't need it. Drag in progress. Now, with prefabs, you can't grab and move an object like that. To circumvent that, we can duplicate our object using Ctrl-D, and then move that copy over. I'll rename it to Progress. Then, if you try to delete it from the prefab, you'll see that you can't. There's a limited number of changes you can make to prefabs, like adding objects or components and altering the parameters, but you cannot delete an object without opening the prefab. To delete it, go inside and locate Progress. Now you can delete it. Okay, great. There's our start menu. You can save it, click here and save scene. You can also get rid of it, remove scene. Now, if we open up the starting scene here. First, save the changes. Here's start menu. Let's create a little script to load the game on startup. I'll give it the same name, Start Menu. Then I'll attach it to a newly created empty object. Now, let's create a canvas inside. First, let me set these to 0. Alright, right-click, go to UI, and Canvas. Now, to cover up this background, create an image. Click here, hold Shift-Alt, and press this button here. This will stretch the image to full screen, effectively making it a background. Let's make it gray. You can choose whatever color you like. I'm just doing what's fastest. Next, right-click Canvas again, and under UI, select Button. We'll call it Go. This works. Now let's add a function that'll get called from this button. From the Start menu, go into the script, and declare a new method. Public void Go, just like that. Just being explicit for the purposes of clarity. Here we specify what happens when the button is pressed. It loads Scene Manager. Let's write .load scene. Now the question is, what index do we pass in? Here, inside the brackets. It depends on how many levels the player's beaten. We need to store that count somewhere. In our case, that somewhere is the progress object. It already has coins, width, and height. Now let's add levels. Create another int, call it level and close off. Back in Start menu. We need to access progress. Since it's a singleton, you can just go progress, instance. Then we pull the level count by adding level. So, these are levels. Well, the last completed level is what's saved here. Regarding the level indexes, go to File, Build Settings. Here, you can see all the levels that'll go into the game. Let's add our starting scene here. Move it to the very top, because the order matters here. As you can see, Start menu is index 0, while level 1 is index 1. As it stands, when the player launches the game, everything's at 0, including the level. When they press the Go button, the starting level loads and nothing happens. To rectify that, let's add +1 here. Save it, and that's pretty much it for Start menu. Create an on-click event for this button. Drag on the Start menu function, and pick the Go method. We finally get to saves. The idea is as follows. We take an object containing all the data that needs to be saved. This data. And we save it to the Yandex server. To implement that, we call a function that sends all this data to JavaScript, which then calls an SDK function to save this data. To streamline this process, let's create a class that'll let us write this class to a file. On the Yandex server, create another class right above progress. Public class player info, let's call it that. Because it's a class, it shouldn't have parentheses. Let's move all these fields into it. So, we've created another class within the script. It's perfectly fine to do that. There's no inheritance from model behavior, just a regular class. Inside the progress class, let's create a public field and feed it the above class type. Player info. So what does that mean? This class used to have fields. We moved them into a different class, and progress now contains an instance of that other class. We just placed all this data into a separate class, which doesn't really change things. Above the class definition, add the system serializable attribute. It makes this object appear in the inspector. Save. You can expect some errors. Let's check the Unity console. Yes, indeed. That's because we're making multiple calls on progress and its fields. However, it no longer has the coin field, but it does have player info, and player info has coins. We just take these scripts that access the progress fields and add player info. This is Coin Manager, which is responsible for the number of coins. Now, player modifier changes the width and height. These properties are nested within player info. That's it. I've made corrections to the 3 scripts, and there are no errors. If we look at the inspector now, we can see this object attached to progress, along with all these. Nothing's changed on the surface, but we now have this object that's very compatible with JavaScript. Now, on to the most important thing. External methods. I've created methods saveExtern and loadExtern. The extern, in the name, just lets us know that it's an external method. DLL import means they're not going to be implemented through C#, but rather in JavaScript. After that, we'll store them in a JSLIB file. It's like this. When saving data, we need to pass in a string with that data. When loading data, there are no inputs, we just tell the Yandex SDK to load the data. We must create 2 methods with the same names in the JSLIB file. You follow? As a reminder, these functions are called from Unity, but executed in JavaScript. I'll add 2 functions here. Mind the syntax. Round brackets, curly brackets, colon, function keyword, and comma right here. Within the actual function block in JavaScript, we need to supply the Yandex functions for saving and loading data. Let's see what they look like. Head on over to player details in the documentation. Probably the longest section there. We've already covered user authorization. Here, in game data, the player.setData method. That's what we need. It takes in 2 arguments, data and flush. Ignore flush. It's an optional parameter that we don't need. As for data, it's an object containing key-value pairs. It's basically an array. These key-value pairs, it's things like coins number, width value, height value. That's what key-value pairs are. Right, this object is usable in JavaScript. Now we're going to convert C# data into a format that JavaScript would understand. That was the setData method. There's also the getData method. How it works is, we pass in an array of keys, say, coins and width. It then returns to us the coin and width values. It says here, if the keys parameter is missing, the method returns all in-game user data. That's the way we're going to use it, without specifying any keys, so it returns all the data. We load in the data just once, at the start of the game. Very convenient. Let's put a pin in that. For now, go to C#, the progress script. So we have this saveExtern method, right? It's executed here, with some data passed in. This data is of type string. We can only pass basic data types from C# to JavaScript: integers, strings, Boolean variables. Things like that. Well, also arrays, but the point is it's simple data. What we want to do is pass in this entire playerInfo object, with all its fields. To achieve that, let's create a new method. I called it save. We'll call it from Unity whenever we need to save a scene. For example, if there are some changes, or a level is complete, or we need to preserve the number of coins, width, and so on, we do it by calling this save method, and we use the JSON utility .toJSON method. Here's what this method does. It takes an object, this one in our case, and converts it into a string. As a result, this JSON string variable ends up with a string that contains all the fields of this object in a certain format. That's it, now we can send it to JavaScript. That's the first. Next, we need to create a method for loading the data. I called it setPlayerInfo. Here, we do the opposite, take a string from JavaScript, and, this time using JSON utility .from JSON, convert this string back into playerInfo. For convenience, I added text output to the screen. This allows us to see all these parameters at startup. This symbol means a new line, so these numbers will appear in a column, listed one after another. Underscore playerInfo text is just text. Here, text mesh pro UGUI. But the main thing is this, which yields us the playerInfo object from the string. Alright, done with the C# part. Let's switch to JSLIB. We've created two functions here, saveExtern and loadExtern. Let's make some changes. Here's their full form. You can find all the scripts from this lesson in the video description. Let's drill down a little. The main takeaway here is that we call player, setData, and save the data. This is the Yandex SDK method. But there are still a few things we need to do with this data. The first function that's called here is UTF-8 to string. This converts a C# string into a string that JavaScript can work with. Next line, we convert that string into an object. That object myObj is the same one that's mentioned here, the one containing key-value pairs. It's what we then save. After all the manipulations with the strings, we get this object and save it. Now, the loadExtern function. It makes use of the SDK method getData. It takes our data. By the way, note the empty brackets, no parameters. It means it loads all the data. Also, look at the syntax here, round brackets followed by then. In JavaScript, these are called promises. Here's how it works: you call a method, which then asynchronously returns its result. We send a request to the server, and then get a delayed response. The game does not pause during this time window between the request and the response. We send the request, it takes some time to get processed, and then we receive it back. JavaScript handles such tasks using promises, introduced by the then keyword. Once the data is received, it triggers then. Here you can see the date variable. You can call it whatever you want. I called it _date. This signifies the variable where the received data will be stored. In other words, the result of this method running, we convert this data into a string, which we then send to C#. You remember the send message method. Pass in the name of the object that has the script attached, the name of the method, and then data. This makes a call to the setPlayerInfo method. As a result, it'll populate all the fields of the PlayerInfo object with the loaded data. And this will display on the screen. I understand it's a bit complicated, but fortunately you only need to do it once. After that, we can use it to save any data. You can add new data to this PlayerInfo object, and they'll also be saved, no changes to the code necessary. The JavaScript code that enables saving, it can be different types of data. Not a problem. There are still some things we need to do. First of all, we need to call the save method, which at the moment isn't done anywhere. Same goes for the load method. Here's what we do: load data at startup. That's why I'll call the load extern method here. The progress object is instantiated, made don't destroy on load, and saved to the instance variable, after which it loads all the data. That's basically it. We only need to load once, at the very start of the game. With save, it's a different story. This should be done every time the values change. Coins, width, height, or level. The number of coins should be saved at the end of the level. The player collects, say, 50 coins throughout a level, and that number needs to be carried over to the next level. That's coins. As for the width and height, they only change on the starting screen. I suggest doing this. We have this game manager script. Here. It's got this next level method here. We're going to save all the data when the player moves to the next level. Before loading a new scene, we access the progress singleton and call the save method. That's it. We also have the play button here. So the player sets the width and height of the character, clicks play, and at that moment we can save the data on the coins spent and the resulting width and height. If you want to save data anywhere else, maybe for some new elements, just go ahead and use this line. We've yet to save the number of levels beaten by the player. We have level here in progress, but it's not set anywhere. We'll do that right here in Game Manager. So, a level's completed, and the player presses a button that takes them to the next level. Let's write progress, instance, access player info, then level and an assignment operator. The level variable stores the completed level. And then we can just do this. Scene manager.getActiveScene.buildIndex, that's the index of the current scene. That's all. Now level progress is saved upon a level transition. Let's now save our own progress here and test. First, we'll check if everything works in Unity. Make sure all the fields are populated. Like here, we created a new text element in progress, in which I want to output a message just to test things out. It's not filled in yet. Right-click Progress UI Canvas. Inside the canvas, go UI, Text. Let's write something like this. A few numbers. I'll position it to the top left. By the way, canvases have an order in which they're displayed, but right now it's hidden behind this gray background. Just increase sort order, like this. And let's make the numbers smaller. Also, it's better to output something else besides zeros at startup. Here, data. After we build the game and first launch it, we should see that everything's nulled here. If we put in zeros ourselves, we won't notice the change, obviously. Alright, drag in text, save, and press play. This logging is normal. We're running the game out of the browser, so it can't access JSLib functions. Click Go, and the game starts. Everything's in order. These logs are all to be expected. It's a shame though that we can't actually play our game in the editor. This error interrupts the function call. Let's refine our code to let you test in the editor like you're used to. Go to Game Manager and find the play method. We can actually solve the problem by just moving this line down here. But there's also a way to get rid of those annoying red errors in the console. Search for platform-dependent compilation in Unity. One of the top results will be this Unity documentation section. You can write code that'll execute exclusively on a specific target platform. Here you have a list of the supported platforms. Editor means the Unity editor, then there's editor on Windows, on iOS, on iPhone, on Android, and more. Your sections of code will work only with these particular platforms. There's also Unity WebGL here. Scroll down, and here you can see the exact way to do it. Hashtag if Unity_editor, and then hashtag endif. You can copy this pre-made code and add it to yours. Change Unity_editor to Unity_WBGL. Be sure to match case. These are performed only if we're within WebGL. That's it. By adding this condition everywhere a red error occurs, you eliminate it. Save, and let's test again. Starting scene, press go. Play mode works. We can control our character. Now let's build it for WebGL. Once it finishes, we'll upload it to Yandex Games. After some time, refresh the page and click the link that says the file's been verified. The game will start. Alright, we can see the numbers. That's good. It's the data that gets loaded into Unity upon startup. They're all zeros because we haven't started playing yet. Great. Press go, and we're in game. Let's collect some coins and complete the level so that values change. Then we'll check if this data will be loaded the next time I open the game. Next level. Let me increase the guy's height. Here, now I have 9 coins and the character is a little taller. Click play. Let's now refresh the page to open the game anew. There we go. You can see here the number of coins, 9. 25 is the character's height, and 1 is the number of the level, instead of 0, which is the last completed level. Click go, and now we're on level 2. Great. Let's test some more. As you can see, the character's height got loaded in as well. It's all in the code we wrote that upon startup the height is pulled from progress and assigned. Next. Level 3. Let's make him even taller. Good. Let's double check. You can create many cookie cutter levels to make the game longer, so it doesn't cut off at level 4. There, the data's loaded. Go. We're on level 3, and our character's width and height are increased. This is it for saving. A big, complex topic to be sure. I want to touch on another little thing in this lesson: leaderboards. We can increase our character's height, right? It's now at 50. It would be interesting to see who's able to reach the maximum height. 500 or even more. Let's see how we can leverage the Yandex SDK to create a leaderboard. There's a dedicated section in the documentation. It's all pretty straightforward. We'll just do some copy-pasting. First, initialize the LB object. This step is necessary to make use of leaderboards. This is done inside index.html. Here. One little thing though. You'd think you just do this, right? Call ysdk.getLeaderboards, it initializes, and this LB variable stores the leaderboard for us to access later. Not so fast. This is something we've encountered in previous lessons. It uses the ysdk object, which you can see here. That means that when this function is called, this object won't have been created yet. To get around that, let's add a function on top. Let's call it function initlib for library. Move this code here. As for the variable itself, place it outside the function. We'll call this library initialization function from here. This code is executed after the Yandex SDK object has been created. This variable now exists and can be accessed. Next, we need to call a function that adds numbers to the leaderboard. Scroll down and copy this code snippet. Get leaderboards and set leaderboard score. That's the thing we need now. Let's copy it all and add a new method to our JSLib file. Give it a name. I'll call it set to leaderboard. Like this. Function, round brackets, comma at the end, and paste the copied method. There are samples for adding scores, with extra data and without. You can read about it in the documentation. We'll use the simpler option. That's pretty much it. Here, we pass in the leaderboard name to which this number relates. We'll create the leaderboard in the console in a moment. It's fast. Let's call it height. There can be different kinds of competition coins, though they fluctuate too much due to spending, levels beaten, and so on. I think height is a fun option. And the number. This set to leaderboard function takes in the numerical height value that we pass in from Unity. And this value is saved as the character's height. Now we need to call set to leaderboard from Unity. Let's see where exactly our character's height changes. I know it can happen in a shop. Here's the shop object. And here's the byHeight function. Then there's the addition assignment operation. And this is where we can call this method. Just like that. This is an external method, so we call it through the DLL import attribute. We declare this method here. Next, we import the interop, services namespace. Now we call this method from here and pass in the character's current height. This value. Save. Let's recap. The player clicks the button to buy height, the height increases, and that value is passed into this method. The method is called in JSLib to then call the SDK method that sets the height parameter in the leaderboard as the one we've passed in. Great, now save it all. All the scripts that we've modified. Next, we make a build. While the project is building, let's go to the Yandex developer console. In here, we have the leaderboard section. It lets you add a new leaderboard. It asks you to enter the string identifier. Let's do it. Height. Below there's the displayed leaderboard name in Russian. You can also do height, or who's the tallest, for example. Is this the main leaderboard? There can be several leaderboards, of which one would be the main leaderboard. Because we only have one, it's grayed out. Further down is leaderboard type numeric or time. The latter can be chosen for, say, time trials, where players compete who's the fastest. Sort order descending or ascending, lists players based on their score. Who scored highest? Descending puts the highest scores at the top. Score offset. Since we have integers, leave it at 0. That's it, click Submit. We've made a leaderboard. Once the game builds, we'll get a score and see how it's displayed in game. The build's ready. Add it to archive and upload it as a draft. The game's been uploaded and verified, and now let's see how tall we can get. I need coins to buy height at least once, so that the leaderboard save method gets called. Next, proceed to the 4th level. Buy height. Maybe we should reduce the height this button adds, otherwise the character can go out of bounds. Looks funny though. That's it. But where can we see the leaderboard? Here, click on the game name. Yellow Man Run. You'll see the game description, and below it top players. This window can be accessed from different places, including from the game's catalog. And here you can see the scores. If you don't see this window, don't worry. After you create a leaderboard for the first time, you may have to wait a bit for it to actually appear. Alright, we saved and loaded everything we needed for our game. Thankfully, it was just a few numbers. In some games, saving is a very difficult task. For example, a farming simulator would require saving the locations of all the objects you've built, their states at the end of the game, and much more. But the approach is largely the same. We save at the moment something changes, and load at the start of the game, changing the scene state based on what we've loaded.